Somebody once told me the world is gonna roll me. I ain't the sharpest.
Hello, my name is Hani Haddadian,
My name is Probman.
My name is Patrick Mackel.
and we implemented the real-time temperature graph.
I worked on the script that had programmed that would eventually be implemented into the GUI.
And I also helped Prob with the script that will be implemented into our GUI, and I also worked on the GUI itself too.
I primarily worked on the GUI, doing a lot of hard work on there.
It was hard making the graph in real time.
Yeah, and some of the challenges that I faced were when we took the code that Prob and I implemented on a script file. It was difficult transferring that code into the actual GUI because we had to use object-oriented programming and we had to define the variables. And that's also one of the problems we faced, is that our code allows the user to pick different variables. So for example, the user can pick which port on the Arduino they want to use, and the user can also pick which port they want to use for the LED. So that gives the user a bit of flexibility, and we also allow the users to pick different sensors. And so we had a lot of variables that we had to keep track of, and in that GUI it becomes difficult to keep track of all the variables and all the variable names and things like that.
I had a lot of issues with object-oriented programming as well. In the beginning of the class it was fairly simple because you could just plug in variables and put in loops. But with object-oriented programming everything had changed, because within those objects we had functions in there and we had loops in there. We had to keep tracks of the variables inside the objects. It was similar to structs, but not similar enough to where it was easy. So we had to do a lot of learning outside of our class time in order to figure out how to do it and implement it into our GUI.
Yeah, and actually the callback functions between the buttons that we made and the actual so the callback functions were very difficult to just get a hang of. But once we got the hang of it, and once we made one or two callback functions, it started becoming just secondhand nature. It started becoming something we could do much easier. So it was difficult at first, but after like 2 or 3 tries, it became a bit easier. But a lot of research was involved just to try to figure out how to do it, because we never used the app designer.
Upon running the program, we can see that there are many user inputs down below. The first one has to do with the port that the temperature sensor is connected to, which can take a value from 0 to 5. Here we will choose 1. Below are the 3 color options for the 3 lines, the Celsius, Kelvin, and Fahrenheit lines of the temperature. We can see down below that we can enter R for red, G for green, B for blue, and Y for yellow. Here we will use R for the Celsius line, G for the Kelvin line, and B for the Fahrenheit line. The enter time option lets the user select how long they want to run this temperature sensing program. Here we will choose 20 seconds. The line width will alter the width of these lines on the graph. Here we will choose 3. And the LED port, which is the port that the LED is connected to here, can take a value from 8 to 13. Here it will be 9. So now when we record, the LED will be turning on. Once it is done recording, the LED will turn off. So let's go ahead and test it out. As you can see, the LED has turned on. Now that it's done, the LED has turned off. Now here we have a statistics option where we can look at the statistics of these 3 lines. So let's go ahead and see what that gives us. As we can see up here, it gives us the average, the standard deviation, and the mode of the 3 different lines. And we can scroll over and find the max, the min, and the variance, as well as the range. Additionally, we have this box to the left for the user to take any notes they wish when they're running this program. Lastly, we have statistics that can be saved in a file called temp data. So we'll go ahead and do that.
So now after we're done running the actual app, we can see that the data is automatically stored into a file called temp data, and that's the file right here. And this stores all of our statistical analysis into a file, and this happens automatically. And now we're going to run through some of our code. So if we look here, the first thing that we have in our code is we set all of our properties, and this includes all the properties that the user is going to input. So the time, for example, the color for the graph, for the Kelvin, and these are all the properties that the user inputs. And then we also have our statistical data, and these are all set for our properties. And one thing to note is that for things like range and mode, we couldn't call the property range because that would mess with the function range that we used. So we had to call it rang and mod. And this is just to make sure that our functions actually run.
So right here we have, as you can see on the GUI, where the user inputted the different colors for the different graphs. For example, for temperature in Celsius, Kelvin, and Fahrenheit, the user will type in either B, R, G, or Y, which are the different colors. So in this moment, when somebody types in the letter B, it will assign it to, it'll check right here, see if it corresponds with the value C, and then it will apply it into the object property called color C, which is Celsius. It'll assign blue to app.colorC and so forth. And it'll also do the same thing here for Kelvin, and then later on it'll also do the same thing for Fahrenheit.
And then here we have something very similar to the if-else statements that we had before, and this is just for the port. So this assigns app.port to the input that the user puts. So if the user enters 0, app.port will become A0. If the user enters 1, app.port will become A1, and so on and so forth. And this allows the user to actually be able to pick the different ports that they want to use, and this will just give the user much more flexibility. Yeah.
This is where a lot of the actual calculations are occurring right here during the graph. So for example, right here we have A is equal to Arduino, which is where we assign the Arduino to the variable A. We have X is equal to 0, which helps us keep track of the time. And then these three parts right here, these three properties, we assign to empty arrays because we'll be keeping track of the data and the temperatures within the arrays. This while loop right here is what will run when we hit the record button, and it'll begin plotting everything. So while the time is less than the time that the user had inputted, it will turn on the LED, it will turn it off at the end, and then it'll increment the time. It'll read the voltage that it gets from the temperature sensor, and then we will convert that into temperature right here. We will draw it, plot it.
And one thing to also note is that you can see the app.colorC right here and the app.colorF right here, and these are the inputs that the user had from the beginning. And then we move on to our actual statistics right here. This is just more of the same stuff that we had from before. So this was one of our reach features, and at first we have the arrays app.average, app.standard deviation, and all of these statistical analysis that we're going to use. We set the arrays equal to empty arrays just to help our code run faster. And so here, I'll take an example for mean, for example. So app.average1 is the mean of the temperature Celsius. App.average2 is the mean for the temperature Fahrenheit, and app.average3 is the mean for the temperature Kelvin. And then we create a matrix, which we just called matrix. And so the first column will be the app.average. So that's the average for the Celsius, Fahrenheit, and Kelvin. And then the matrix just does the same thing for all of the other statistical data that we used. And then here, this is the code to actually run the to actually display the matrix up here in this. And then we finally have the save, and this is what automatically saves the data onto a file called tempdata.mat, and that's what does this right here. And that's basically our code. Thank you. One thing to also note is that the user can zoom in and out of the graph. We can zoom in here and we can see the actual change in the line. If we zoom in more, we can see the actual temperature at different times. And we are sitting in a room, and so it's at room temperature. It's a bit cold, but we can see that the average temperature is around 21, which shows that we actually had the correct temperature reading. And one thing to note is that because we have 3 lines in the graph, when the user actually runs it, they won't be able to see the small changes in the temperature. However, if a large change does occur, then that will be clear on the graph.